PlanetScale's sharding technology has only ever been available on the enterprise plan, up until now. We just released our first workflow, which allows you to horizontally scale your database tables with sharding. Let's walk through an end-to-end example of how to take an unsharded table in your PlanetScale database and shard it. Now, I'm going to touch on some concepts here that might be unfamiliar to you if you don't have experience with Vitess. To keep this video short-ish, I am not going to go too in-depth on those concepts, but I do have some follow-up videos coming out shortly on each of those, and until then, you can find links to all of the docs in the description below. And one more thing before we get into it, PlanetScale and Vitess provide some incredibly powerful technology to shard your tables, but there is some upfront design work that you need to do to design a performant sharding scheme. So that is quite out of scope for this video. However, I have a different video that goes over how to avoid things like cross-shard queries. I'll link that video here and below, everywhere. Please, 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 I beg of you, go watch that before you get into this. All right, I'm assuming you want to watch that. Let's get started. All right, so here we are in our PlanetScale dashboard. The database tables that we want to shard are in this metal database. So this metal database is the database for a gym tracker application. I'll go through some of the schema in a bit here. But the first thing we want to do is go to this cluster configuration panel. So we'll click on that. Down here, you see this metal keyspace. So in Vitess, a keyspace is what we call a logical database. It's basically a container around your clusters. So right now in this unsharded database, we have a single keyspace, metal, and it essentially looks like this here. So you have this big box here is going to be the keyspace, and inside this keyspace, we have one primary and two replicas. When a new request comes in, it gets routed through our global edge network, which then sends it to the load balancer or the VT gates, and the VT gates are responsible for routing the queries to the correct keyspace and shards. So the first step in sharding some of our tables is we have to add a new keyspace, and the new keyspace will hold the shards that we want to add. So over here, we're going to go ahead and click new keyspace. I'm going to name this metal sharded. Over here, you can choose the number of shards. We'll just do 2 for this example. And then over here, you pick your cluster size. I'll stay on the PS10. You can also choose to add additional replicas. Again, as you saw in that diagram, each keyspace cluster comes with one primary and 2 replicas by default. We're just going to stick with that. And down here, you can see the cost. So this cost is in addition to this other existing keyspace you have. One thing to note here is once you start moving tables from this unsharded keyspace to the new sharded keyspace, most likely that unsharded keyspace is going to get much smaller, and usually you can downsize to a smaller cluster size. So in the end, it somewhat works out to a similar price. All right, this all looks good. So let's go ahead and create the keyspace. So while this is initializing, let's actually have a peek at what this new architecture now looks like. All right, so before we only had this single unsharded keyspace here. Since we added this new sharded keyspace called metal sharded, this is what our full PlanetScale cluster now looks like. So you have, again, that old primary and 2 replicas over here. And then in the sharded keyspace, we have now 2 shards. Each shard has its own primary and replica. So in total, we now have 3 primaries and 6 replicas in this cluster. And then if we come back to our dashboard, now that that's done initializing, you can see here that same architecture reflected in your dashboard. So this is the metal sharded keyspace. We have 2 shards here. You can click through each of those and see the different primaries, replicas, and then of course you can go back and look at your other original keyspace as well. Now we need to choose which tables we want to move to this sharded keyspace. Let's go take a look at our existing schema right now. So this is that unsharded keyspace. We haven't moved any tables over yet, so the sharded one is still empty. You can ignore some of these tables here. These are just Laravel default tables, but over here we have this exercise logs table. Down here we have exercises, we have a programs table, and finally our users table. So the table in particular that we want to shard here is the exercise logs table. This gym tracker application, every time a user logs a new workout, they're creating multiple exercise log entries. So as you can imagine, this exercise logs table grows much, much faster than all these other tables here. If you have a large database, you might have a table in particular that is always causing you problems. Backups take forever, queries are starting to slow down. For this example, that's going to be our exercise logs table. Usually that makes it a good candidate for sharding. Again, I'm not going to cover sharding design in this video. Please go watch that other video if you need help with that. But let's say right now this exercise logs table is our problematic table. So we're definitely going to shard that. Likewise, you can see here, there's this user ID that references this users table down here. And there's also an exercise ID that references this exercises table. So to avoid cross-shard queries, we're actually going to move all three of these tables to the sharded keyspace. Maybe for our application, it's a common query pattern to join all three of these tables. Maybe every time a user logs in, they want to see their workout for a particular day. We would have to join all three tables here. So it makes sense to move all of these to the same keyspace, and ideally every user's activity as well as the user's entry itself should be on the same shard as well. All right, so we've chosen the three tables we're going to move to this sharded metal keyspace. The next step now is to choose vindexes for each of these tables. So in Vitess, every single sharded table has to have a vindex. The vindex is essentially what tells Vitess how to distribute each row of data across the shards. And the primary goal here in choosing a vindex is to ensure, one, that data is evenly distributed, and two, that we avoid cross-shard queries as often as possible for your most common query patterns. Now, it's nearly impossible to avoid cross-shard queries for every single query in your application. What we're trying to optimize for is the most common query patterns. So in Vitess, there are a number of different predefined vindexes you can choose from. For this video, let's say we chose the XX hash down here, which is a fairly common vindex option. And then over here for the exercise logs table, we're going to hash this user ID. And for the users table, we're going to hash the ID. I go over in depth why we pick these vindexes in the other video, so feel free to watch that if you're curious. The reason I picked it though is this ensures that all of the user data and all of that user's exercise logs always are guaranteed to end up on the same shard. All right, so to add the vindexes, first, we're gonna go back to this branch. We have safe migrations enabled, as we always recommend. I'm gonna click new branch here, and we'll call this vindexes, create the branch. All right, and to add those vindexes, we're gonna come to the console here, and we need to modify the v schema of the sharded keyspace. So we'll connect to that dev branch here. And now to target that keyspace, we're gonna do this, use metal sharded. Now, any queries we run are directly on that sharded keyspace. Targeting keyspaces like this is essentially the same as when you say use database name, but instead you're just saying the keyspace name. All right, I'm going to just copy and paste this command in. I will leave some docs below where you can copy and paste this and see this whole tutorial in a written format as well. So what we're doing here is altering the v schema for the exercise logs to add that vindex where we're running the user ID through the XX hash function. So we'll run that, and then same thing, but for users. All right, and now that we've made those changes, we can go back to that branch and deploy this to production. So you see over here, updated v schema. You can switch to the sharded keyspace and see the diff here of what changed. So before, the v schema was pretty much empty besides the fact that it's sharded. Now we added the vindexes here. We added the tables, exercise logs, and users along with those vindexes. So let's create that deploy request. And I will deploy that now. Delete this once it's done. Cool, and now that's deployed, we can go back to this cluster configuration panel, click metal sharded here, click v schema, and you see that updated v schema now. Just for the sake of maybe curiosity, if we go to this metal one and click the V schema here, you can see this one is currently empty. All right, so all the prep work is now done. So now to shard your tables, we're gonna run a workflow to move your tables from the unsharded keyspace to the sharded keyspace. In PlanetScale, a workflow is basically the same thing it is at every other application. It's essentially just a set of predefined steps to execute some action. So we only have one workflow right now, which is this move tables from unsharded to sharded keyspace. If you're a Vitess user, this is equivalent to the Vitess MoveTables workflow, as you might have guessed by now. One of the cool things about the PlanetScale MoveTables workflow is that we run a lot of stuff in the background for you that you would normally have to do manually with Vitess. So creating sequence tables, moving the tables over, updating your V schema on the unsharded keyspace. That's all handled here, as you'll see shortly. So to start, click New Workflow. We're going to name this Shard Exercise Logs and Users. So over here, you'll click the source keyspace. So this is the keyspace that currently holds the tables you want to move over. So for us, that's metal. We're going to select the tables we want to move. So that's exercise logs and users. And then the destination keyspace where we want to move it is this metal sharded keyspace. If all that looks good, you can go ahead and click validate. And this just goes through the checklist of all of the requirements to run the workflow. So this just covers all the things we already did, adding the vindexes to the V schema, safe migrations are on. You can read through this, but if you see any issues here, you'll have a red X icon instead of the green check mark. And then check out the docs. The docs will cover all these issues. This all looks good, so we can proceed. All right, so as soon as you hit start workflow, you enter into the copying phase of the workflow. So during this phase, Vitess is copying the rows for the tables you want to shard from your unsharded keyspace to the sharded keyspace. All you really have to do right here is monitor these logs below to make sure everything looks good. Now you can see here, once all that data is copied over to the metal sharded keyspace, you will get this button here to verify data. So this just shows that all the data has been copied accurately and is up to date. So we'll click that. It's now verifying across the two different keyspaces. And I should mention right now, the fact that we're copying them over doesn't mean we're erasing it from the old keyspace. This data exists on both keyspaces right now. So currently this metal keyspace is still serving all traffic for this database. This metal sharded keyspace is essentially acting as a replica. We've replicated all data over to it, and it's continuing to replicate back and forth as new stuff comes in. And I do have a sample application running right here that's using this database. It's currently targeting that metal keyspace directly. So you can see here, all of the information is working. Everything is pulling in correctly. You should, throughout this process, every next phase, check your production application to make sure it's working. Okay, as soon as that data was verified, we entered into what we call the running phase. So during this phase, we're using pure binlog-based replication to keep these two keyspaces up to date with each other. Again, right now, this old metal keyspace is still serving all primary and replica traffic. So if a new query comes in, it's going to be directed to this keyspace. The end goal, though, of course, is for queries that involve this exercise logs table or users table, we want them to go to this sharded keyspace. So to do that, you have the option to switch all traffic to be routed to the target keyspace, so this metal sharded keyspace. So anytime a new request comes in that involves those tables, the request will be fulfilled by this sharded keyspace. You can start, if you want to be cautious, by switching only replica traffic. If you want to do that, just click here and then go ahead and click the button. We are just going to switch all traffic right now because this is obviously not a real application. So I'll click that. All right, so now any traffic that comes in querying this exercise logs or users table is going to this metal sharded keyspace. So we should check that our application still works correctly. So here's the users table, refreshing, it all looks good. This is our exercise logs output, so all of this looks good as well. If things do seem weird for you, you can come to this Insights tab here, and you can actually see on your Insights graph where you started switching states during the workflow. So this might help you to investigate any issues here. If you suddenly see a bunch of errors or something like that associated with a certain state, that kind of helps you to start debugging. You can also write into our support team. I know this is a new feature and kind of complicated to get your head wrapped around. So feel free to reach out to us. We're here. Also, we have a Discord channel. Feel free to hop in there. We always have employees chatting in there. All right, back to our workflow. We'll click into this. Everything looks good so far. The next step really is to complete the workflow. Before you do that, there's a very, very important step that you need to do. So once you click that button to switch the traffic to serve from the sharded keyspace, we actually put some routing rules in place behind the scenes. The routing rules are responsible for routing traffic to the correct keyspace. However, once we click complete workflow, PlanetScale is going to remove those routing rules. So your application is just kind of on its own. Now, if this is the first time you're sharding a table, your application configuration code probably has a section where it says database name, and you have set that equal to metal or whatever your database name shows up here. That's not going to work because now that you have multiple keyspaces, Vitess is going to think you're directly targeting this metal keyspace. It's not going to know that you actually have some tables over here. So the fix for this is pretty straightforward. What you need to do is update your application configuration code now to target at primary instead of the database name. So in my little Laravel application here, you can see I have metal as the database name. I'm going to change that to at primary. I'll save that. And now if we come back to the application, when I refresh this, hopefully it does continue to work. There we go. All right, I don't know what that means, but look, it eventually gets the stuff here. So all good. And we check our users page. Again, I don't know what this means. Broken pipe. Maybe if I restart the server, I'm just running this locally. Let's see. There we go. It works. Just turn it off and turn it back on again. Okay. So in your own application, you'll need to figure out where that configuration code is and go ahead and push the change to update that before you click complete workflow. Again, ton of docs in the description that will help you do this. There's different instructions for different frameworks and things like that. We've tried to include as many as possible. Again, if you have any questions, we'd much prefer you reach out to us before potentially breaking the connection to your production database. So you always have that line open. All right, everything looks good here. So I'm gonna go ahead and complete this workflow. Another warning, make sure everything's good. It looks good, we'll complete it. You have one more chance to go back and put those old routing rules back in place. So let's make sure again that everything's working correctly. Let me refresh. All right, it all looks good. So over here, I'm gonna click my application is working. Yep. You now have a sharded database on PlanetScale. If you come back and look at this architecture again, so we'll look at the shards, you see here the two shards are split into these two different ranges. They're pretty much evenly split in half. So we can actually go check which data lives on each of these shards. If you're interested, you can come to your console, connect. All right, and we can actually target those shards directly with using that same use syntax as before. So I'll just paste it in. We're gonna target the keyspace first and then the particular shard. So looking at this first shard, let's see, select all from users. Okay, there's actually no users on this shard. That table only had, I think, 4 user entries into it, and then I think maybe 6 exercise logs or something. So probably not the best example to show like a good even distribution. We should expect, if no users are on this shard, select all from exercise logs. The hope is that there are no exercise logs on the shard either, because like we said, all of that data for every user should live on the same shard as their exercise logs. Let's see. Okay, good. Well, now let me clear this. We should probably make sure the other shard has some stuff on it. If not, that's not good. All right, so now we're gonna use, again, the middle sharded keyspace and directly target this other shard. If it's not here, I don't know where it is. All right, select all from users. There we go. All right, so we have all 4 of our users are actually on this shard, and then boom. Okay, cool. All of their exercise logs are on this shard as well. So in a real application, you'd have much, much more data if you're to the point where you're sharding a table. So it would likely be evenly distributed amongst all of your shards. And that is it. You now have a sharded database. I hope you enjoyed, and I'll see you in the next one. Bye.